question of whether there are code limitations on the ampacity of electric water heaters, particularly in residential settings, is a common one. Specifically, it touches on the perceived limit of 150 amps for residential water heaters. Let's delve into the details of this issue and explore potential solutions, keeping in mind that electrical codes can vary by jurisdiction, so consulting your local authority having jurisdiction, or OJ, is always crucial. Firstly, the notion of a 150 amp limit for residential electric water heaters warrants closer examination. It's important to pinpoint the specific code section that imposes this restriction. It is essential to verify this against the most recent edition of the National Electrical Code, or NEC, and any local amendments. The NEC provides comprehensive guidelines for electrical installations, and it's the authoritative source for such regulations. Secondly, the NEC requires that electrical equipment be sized with a certain amount of overcurrent protection. For a continuous load, such as water heaters, the NEC typically requires that the overcurrent protection device, like a circuit breaker, be rated at 125% of the appliance's nameplate current. This means that if a water heater draws 100 amps continuously, the circuit breaker protecting it must be rated for at least 125 amps. This is to prevent nuisance tripping of the breaker due to the continuous nature of the load. Thirdly, it's important to distinguish between residential and commercial applications of electric water heaters. The NEC often has different requirements for these two categories due to the differing usage patterns and safety considerations. Commercial installations typically have more stringent requirements, reflecting their higher demand and potential for greater risk. If the customer is considering installing a commercial electric water heater in a residential setting, it's essential to determine whether this is permissible under local codes and whether the existing electrical service is adequate to handle the increased load. Fourthly, the inquiry mentions the possibility of finding a water heater that utilizes multiple circuits for multiple groups of elements. This is a viable solution for high-demand applications where a single circuit would exceed the ampacity limitations. By distributing the load across multiple circuits, the overall current draw on each circuit is reduced, making it easier to comply with code requirements. When considering a multi-circuit water heater, it's crucial to ensure that the electrical panel has sufficient capacity to accommodate the additional circuits. Each circuit must be properly sized and protected with the appropriate overcurrent protection devices. Fifthly, gas-fired water heaters are presented as an alternative. While gas may not be available in all locations, it's worth exploring this option if it's feasible. Gas water heaters typically require a smaller electrical connection for controls and ignition, reducing the electrical load in the system. However, gas installations have their own set of code requirements, including proper venting and gas line sizing. Sixthly, when faced with ambiguity or conflicting interpretations of the electrical code, it's always best to consult with a qualified electrical inspector or a licensed electrical engineer. These professionals are familiar with the local codes and can provide guidance on the most appropriate and code-compliant solutions. Obtaining a written interpretation from the HA can provide clarity and protect the installer from potential liability. Seventhly, if the customer is set on installing a high-recovery electric water heater and the existing electrical service is insufficient, it may be necessary to upgrade the service. This involves increasing the size of the service entrance conductors, upgrading the electrical panel, and potentially working with the utility company to increase the available power. Upgrading the electrical service can be a significant expense, but it may be the only way to safely and reliably power a high-demand appliance. Eighthly, when selecting a water heater, it's important to carefully consider the customer's hot water needs. A high-recovery water heater may not always be necessary, and a more efficient standard model may be sufficient. Performing a load calculation to determine the actual hot water demand can help to avoid oversizing the water heater and incurring unnecessary costs. Ninthly, when installing any electrical equipment, it's crucial to follow the manufacturer's instructions and recommendations. The manufacturer's instructions provide specific guidance on wiring, grounding, and other installation requirements. Failure to follow these instructions can void the warranty and potentially create a safety hazard. Tenthly, grounding is a critical aspect of electrical safety. The NEC requires that all electrical equipment be properly grounded to provide a path for fault current to return to the source. This helps to prevent electrical shock hazards and protect equipment from damage. The grounding system must be properly sized and installed in accordance with the NEC. 11thly, bonding is another important safety measure. Bonding involves connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same potential, reducing the risk of electrical shock. The bonding system must be properly sized and installed in accordance with the NEC. 12thly, overcurrent protection is essential for protecting electrical circuits from overload and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The overcurrent protection devices must be properly sized and installed in accordance with the NEC. 13thly, wiring methods are specified in the NEC to ensure that electrical conductors are properly protected from physical damage and environmental conditions. The NEC specifies different wiring methods for different applications, such as rigid metal conduit, electrical metallic tubing, and non-metallic sheet cable. The appropriate wiring method must be selected based on the specific installation conditions. 14thly, conductor ampacity is the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The NEC provides tables that list the ampacity of different conductors based on their size, insulation type, and installation conditions. It's crucial to select conductors with sufficient ampacity to handle the expected load. 15thly, voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and reduce its efficiency. The NEC recommends limiting voltage drop to a certain percentage of the source voltage. It's important to calculate voltage drop to ensure that it's within acceptable limits. 16thly, arc fault circuit interrupters, or FSIs, are devices that are designed to detect arc faults, which are a common cause of electrical fires. The NEC requires FSIs to be installed in certain locations, such as bedrooms, to provide enhanced protection against fire hazards. 17thly, ground fault circuit interrupters, or GFCIs, are devices that are designed to detect ground faults, which are a common cause of electrical shock. The NEC requires GFCIs to be installed in certain locations, such as bathrooms and kitchens, to provide enhanced protection against electrical shock. 18thly, surge protection devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges which can be caused by lightning strikes or other electrical disturbances. SPD can help to prevent damage to sensitive electronic equipment. 19thly, when working with electricity, it's always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and energizing circuits before working on them. It's also important to be aware of the potential hazards of electricity and to take precautions to avoid electrical shock and other injuries. 20thly, the NEC is updated every 3 years to reflect changes in technology and best practices. It's important to stay up to date with the latest edition of the NEC to ensure that electrical installations are safe and code compliant. 21stly, electrical codes are constantly evolving, and it's essential to stay informed about the latest changes and interpretations. Consulting with electrical professionals, attending industry training, and participating in code development activities can help to ensure that you have the knowledge and skills necessary to comply with the latest requirements. 22ndly, consider the water heater's energy efficiency. Look for models with high energy factor, or F, ratings. Higher EF ratings mean the water heater is more efficient at converting energy into hot water, saving money on energy bills. 23rdly, think about the water heater's lifespan. Tankless water heaters generally last longer than tank-type water heaters. However, tankless water heaters may have higher upfront costs. Weigh the pros and cons of each type to determine which is the best fit. 24thly, factor in the cost of installation. Installation costs can vary depending on the type of water heater and the complexity of the installation. Get quotes from multiple contractors to ensure you are getting a fair price. 25thly, consider the maintenance requirements. Tank-type water heaters require periodic flushing to remove sediment buildup. Tankless water heaters may require occasional descaling. Factor in the maintenance costs when making your decision. 26thly, if the water heater is located in an area that is prone to freezing, consider a model with freeze protection. Freeze protection can help to prevent the water heater from freezing and bursting in cold weather. 27thly, think about the noise level. Some water heaters can be noisy, especially tankless models. If noise is a concern, look for a model with a low noise rating. 28thly, consider the warranty. A good warranty can protect you from unexpected repair costs. Look for a water heater with a comprehensive warranty that covers parts and labor. 29thly, think about the environmental impact. Electric water heaters produce no emissions at the point of use, but the electricity used to power them may be generated from fossil fuels. Consider the environmental impact of your water heater choice and look for energy-efficient models. 30thly, when selecting a water heater, it's important to consider all of these factors to ensure that you choose the best model for your needs. Consulting with a qualified professional can help you to make an informed decision. 31stly, it's important to understand that the electrical code is a complex and evolving document. It's essential to stay up to date with the latest changes and interpretations to ensure that electrical installations are safe and code compliant. The best way to address the customer's concerns and ensure a safe and code-compliant installation is to consult with a qualified electrical contractor and the local authority having jurisdiction. By working together, they can determine the most appropriate solution for the customer's specific needs. Finally, always remember that electrical work should only be performed by qualified and licensed individuals. Improper electrical work can be dangerous and can create a fire hazard.